I am really thrilled to have a chance to talk here today. And what I'm going to do is sort of go back and forth, a little bit of history. I want to bring you, I was thinking about this being the 10th anniversary of this event, and I thought it'd be fun to sort of go back in a little bit of our own history in my company, but also talk a little bit about how this show has grown over the years, because it is something that's really special. But first off, it's October. And you know, it's one of those things, like October's pumpkins, it's fall, it's leaves, and at the same time, it's also something we've been coming here now for 10 years. And I was fortunate enough to be here when the first show happened, and it's been a terrific thing. So I think if Pat's in the room, I'd like to just have a round of applause for everything that she has done to make this special. Couldn't bring the puppy. United wouldn't let me bring him. I've had the fortune to talk a lot in my career, and one of the things that I've always remembered is the time where I was most intimidated. And it's always good to talk about a story that makes you look a little foolish. But I had the chance to have a wonderful opportunity to be the person to give the award to Scott Carpenter and John Glenn on the anniversary of their 50th flight. And it was at the Smithsonian Museum a couple years ago. And it was one of those moments where initially I was told that, well, what you're going to do is just introduce them, and they're going to talk about their storied career and everything they've done in their 50-some-odd years of flight. And I said, well, it's a wonderful honor. I'm happy to do that. Then a little bit later into the discussion, the coordinator came up to me and said, well, there's a slight change in the discussion. We actually want you to talk as a keynote. And I was like, well, that would have been nice to hear a little sooner. And then a little bit later, the same person comes by and peeks around the corner and said, Mark, I have something to tell you. And it's like, okay, what else could happen here? He said, well, John and Scott are a little tired. They'd rather go in the beginning of the event. And I thought about that for a second. It's like, fine, well, of course they're tired. Then I realized he was telling me he wanted me to follow John Glenn. And I started to realize that maybe this wasn't going to be such a good idea anymore, because everything I was going to say was going to seem fairly irrelevant when John finished his talk. And then finally we were getting ready to go out, and we were in the green room, and the guy pokes his arm around and he said, you're going to kill me. And I was like, yes, probably. And he said, well, John and Scott told me this is probably going to be the last public event they do together. And you're going to be doing this talk right in front of John's capsule. Then he ran out the door. And I thought about that. I was like, what could you possibly say after that and standing in front of the two of them? So I basically threw out my speech. And what I talked about was two things, really. One was that in that room when I was sitting with them, they didn't talk about their history, their career, or anything. They wanted to ask me questions about what I was doing. They wanted to know about the future. They wanted to know why I was doing what I was doing. And then Scott got into all his technical questions, and it was not a word about their storied career or all their honors and their history. It was really all about the future. And I sat there that night and I said to myself, that's what our industry is about. To be at that age with that kind of history and not be looking backwards and be looking forwards. And I think a lot of what we see in this show and the crowds here, I've developed friendships from this event that have lasted over the years. And someday I hope I can be in his position and have that much kind of passion in the late 80s of my life and still want to be thinking about, he wanted to know if he could come fly with me. He said, well, I got on the shuttle in my 70s. And I said, John, if you want to come fly with me, I'm not going to say no to this one. I'm not going to talk too much about our company. It was a nice introduction. We do quite a lot of things in our business. We're pushing now 50 years as a company and 26 years in the space business, about 2,800 people. I think we're most proud of the fact that we've been able to grow and be profitable for now almost 15 years, which in our industry is really, really tough to do. We've been fortunate enough to be on over 400 space missions. We're launching something this year every 3 weeks to space, and really have built a lot of hardware. And we know how hard it is, and we know how hard it is to go from a small company to become a large company. And last year we celebrated our 25th anniversary in space, and we went back and I realized, to me, a lot of times I get the question, what's the coolest thing you've ever done? And people think about Dream Chaser, and that is a wonderful thing. I'll talk a little bit about it. But to me, the idea of some kid coming off of a farm being able to develop something that could actually go to Mars, that's a pretty much an American story. We've been to 7 planets. We are now on the program to go to Pluto. And many of you know Pluto, unfortunately, it's a 10-year New Horizons mission. It's going to get there in about 7 months or 8 months. And we're finally going to get a close-up look at Pluto. And we're part of that program. And when it launched, Pluto was a planet. And the saddest phone call I think we've had to make was call the satellite. It was going 20,000 miles an hour for years, working really hard, avoiding all the debris. And excuse me, you're not a planet anymore. It was pretty heartbreaking. So I'm the leader of the Make Pluto a Planet Again Society. Right? We also just signed on to the mission that's going to go to the closest to the sun that we've ever done. About 4.5 million miles from the sun, and that's really close for those of you who know anything about planets. So to be able to do that kind of breadth has just been fairly amazing for us. And a lot of us know this picture, and it's one of my favorites for many reasons. The first time that a human had actually taken a picture of the Earth, it was, I wish as a speaker you could have this kind of setup where you're coming around the moon, it's Christmas Eve, you're about to read from the book of Genesis, and then you see this picture and you take it with your camera. I mean, it doesn't get any better than that. Disney couldn't have scripted it any better. And it is a wonderful picture for all of us in the space industry. But it also was the start of really our understanding our planet and being able to do something different with our planet. And most of the organizations that go back to that time say they really began looking at this in a different way. And I think part of what we do in the commercial space business is really try to look at things in a different perspective. And it's pretty important. We were fortunate enough 10 years ago, I went back and thought a little bit, it was a little over 10 years ago that we sent Spirit and Opportunity off to Mars. And we were a significant part of that program. And we got the initial direction that the mission was going to be a 3 to 6 month mission. And that's what we had to size our mechanic. We did a lot of mechanisms and actuators and things on this. And it turned out to be now a 10-year mission. So it's a pretty good thing. And could you imagine, you're all part of this, when you walk into a room of really smart people and say, we're going to take your rover, we're going to put it inside this really big beach ball, we're going to throw it outside of a spacecraft, it's going to hit Mars, it's going to bounce maybe 5, 10, 20 times, and then it's going to open up, and the actuators we built are going to make this thing open, and rover's going to drive off, everything's going to be great, just sign on the bottom line. That was pretty much what happened, and you can imagine seeing things differently. They had a problem, and the people who did this, which wasn't me, but the people who did this were really creatively solving that problem, and it worked perfectly twice, and we have rovers that lasted 20 times longer than they were supposed to. I get this call, I tell the story a little bit, I get the call occasionally from the people on the program, and they pick up the phone on periodic anniversaries of Spirit and Opportunity, and they start cursing me. And rarely, I mean, I get cursed a lot, it's part of the job, but rarely you get cursed when you do something that's lasted 20 times as long as it's supposed to, that you brought in on budget and works. And that's not normally what most of us would like to be cursed about, but the problem is some of them can't leave the program until these rovers die. So they blame us because our stuff works too well, and they have dreams of rover suicide. They're going to take a little joystick and drive the thing off the side. It's pretty funny. Obviously, 2 years ago, a little over 2 years ago, we landed Curiosity on Mars, and the 7 minutes of terror, we all watched it. And we were fortunate in my company to be part of the last 1 minute of terror. And it was truly a Valium moment, as they say, when they realized that you're going out to Pasadena and being able to be part of this. And we realized that they're going to be able to, we all went out there thinking we're going to fail or succeed together. And there's a whole group of companies and JPL and a wonderful team. We realized that we're going to see individual pictures of every step along the way as you came down, which those of us who were part of the building team realized that means if any of us screwed up, we're going to know which one screwed up instead of being able to be successful or fail together. And guess who's at the end of that screw-up line? We did the descent braking system to help this thing land. So I quickly realized that we were going to be in front of 400 million people and my closest personal friends, and we're going to see whether or not we were successful. And that's the moment, I think, when you talk about the space industry, that you realize why do we do what we do? We sit there and are watching, we're landing something on Mars that's going to look for life. It doesn't get much better than that, except that it worked. So it was a pretty fun thing. And this is one of my favorite pictures from Mars. You've seen it was one of the first high-definition pictures of the really, really special arm that does the drilling and the manipulation on the surface. And many of us have seen this, but what's really cool about this is all the things that have come out of it. We're part of this whole program, and we're seeing that the stuff that makes this work, it's an arm that works 340 million miles away and turns 6 degrees. It's now being used for prosthetics. The technology behind it is going to help the soldiers who come back, who need to get better arms and legs. We're looking at sensors that are being used. We're looking at the drilling industries, figuring out how do they do this and how do they get this kind of drill in such a compact, and so many different industries out of the space business. And sometimes we don't talk enough about why space. People think about it as an adventure and a journey and excitement, but it's actually super practical and it does so many different things for us. That's our next rover. So 10 years from now, Pat, we're going to be talking about this guy. I don't know how many of you have ever seen this, but one of my favorite things to do is to talk about things that have not been talked about very much before. One of my personal heroes in aviation, my family goes back in aviation many, many years, and that's Alexander Graham Bell, the inventor of the airplane. And most people I talk to look at me blankly like you all are doing, but he and his wife, Mabel, did 3 really important things in aviation. So at the end of his life, Mabel was his muse, and it's you have somebody who just is part of your life and knows everything who you are and what you do. And Mabel was that muse. And Alexander invented the telephone for her. She was deaf. He was a deaf teacher of the deaf. And he wanted to talk to her because he was in love with her. So that was the motivation for him to invent the telephone. He wound up wooing her, and they stayed together for 50 some odd years. Towards the end of her life, she came up and said, Alexander, I think you ought to look at this lighter than air thing, because I think it is going to make a lot of sense. And he was pretty grumpy at the time, and he didn't really care about it. He's like, I'm not going to go anywhere. I don't want to go anywhere near this. But she persisted, and she did 3 really amazing things. First off, she convinced him to put his mind on it. And he did something. He went to the Wrights. The Wrights had a problem. They took off. But for those of us who know about airplanes, there's a really important thing you need to do with airplanes, 2 important things. You need to be able to land, and you also need to be able to turn. They hadn't figured out the turning thing. So he put his mind to that and looked at a technology that resulted in what we now have for flaps, for ailerons, for rudders, the hinging of the surface. He took an existing technology and helped apply that. Really big thing, because every other airplane in the history of, virtually every other airplane follows that. The picture in the upper right is really the predecessor of this meeting. He started the first aviation association, and there were 5 people involved with it. It was about the membership that was at ISPCS when we first started. It was about 12 of us, I think, in that time. But he started that, and one of those guys is Glenn Curtis, who went on to do all sorts of amazing things. But his wife, Mabel, was taking money out of his pockets for 50 years and funded the first X Prize, the first aviation prize for aviation, where they put out a fair amount of money at that time. I think it was $100,000, and put it towards anyone who could figure out how to develop an airplane that could be commercially practical, which is the airplane in the bottom, called the Silver Dart. And so she did that. She got him into aviation. She started the first X Prize. And the third thing she did, which is not really much of a history book, she was, I believe, the first woman pilot. She got into the vehicle. And because she was deaf, he was very practical. He said, Mabel, you're very good. You're deaf, but you're very good with tuned to vibrations. Can you be my vibration computer, basically? So she got in and flew, and I believe she was probably the first woman pilot, but I don't know that to be certain. But pretty amazing story. And I grew up in that kind of environment. That's where I started flying when I was a young boy, a little field up in New York State. And my family was all into the history of aviation and why it's important. And I was taught from a very early age that you need to respect the future, the past, and because it's really the key to the future. And it's what we believe in my company. It's what we believe in our programs. And when we started developing our Dream Chaser, we really looked back on the history of the space shuttle. And many people like this. It's sort of little brother, big brother, and it's a pretty cool image. And it is to scale. The difference, what you don't actually see, is that the volume inside of Dream Chaser, usable volume, is about the same as the pressurized volume inside the shuttle. Doesn't look that way, but it is. And we developed this over a period of time. We started in, the vehicle is not ours originally. It was a 1970s NASA vehicle, 1980s, called the HL-20, which is really based on a Russian vehicle called the Bor-4. So we have to give credit to 10 years worth of NASA work and some development that was done by the Russians. And we took over the program now about 9 years ago, and began developing it into what we see today. And it's been a pretty good journey, but that journey can't really happen without an awful lot of partners and friends. And my favorite picture from the shuttle program, because you see all these people, you don't know if they're contractors, you don't know if they're NASA, you don't know where they are from the country. It is a team effort. And in my view, in my company's view, building a team around these kinds of programs is really the only way to go. And we've been fortunate enough to do that. We have over 30 different organizations that are now signed on and been helping us. And as an entrepreneur, I think the first thing that you learn, or you hope to learn, is, my view when I talk, is that you have to learn what you don't know and what you're not good at. It's really the toughest thing, to be able to say to yourself, because you're inherently someone who thinks they know everything when you start your own company, but you realize very quickly that you don't. And what you do then, I think, is the mark of whether or not a company becomes successful or not. And in our choice, we went out and said, there's so many good companies, so many good people, that we want to bring as many as we can to the table. And we actually have people in 32 states working on this program right now. It's a pretty big impact. And as importantly for me personally, since we started as a small company, is that is a very significant small minority and disadvantaged business partnership. We put a significant part of our business, right now 15 or almost 15 to 20% of this program is in that area. And it becomes one of those things that self-perpetuates. You get people going, you get small companies going, you give people a chance, and they do just amazing things. And we're really fortunate from it. I know earlier in the show you had folks from Houston here. And one of the fun things to be able to do is to sort of think outside of the box. And the city of Houston, and I think Arturo may be here, really started thinking outside of the box when they wanted to turn Ellington into a potential spaceport. We got together and we signed an agreement to work this together a number of months ago. And it was, for us, a couple of really, really important things. The first was that we wanted to show that we could land in really any airport, which we can do. And then secondly, it was one of those moments where you realize sometimes you can do something that really makes a difference. And in my case, Houston has been such a big part of the space program for 60 some odd years, but space has never returned home to Houston. And we started thinking, wouldn't that be a pretty cool thing to be able to bring something home to Houston, land it there, and have the people, which are now 3 generations of people in the Houston area, celebrate the fact that they've really been part of the space program. So I'd like to thank the city of Houston and Arturo for that, for what they're doing. It's really, I think, a very special project. We also have been fortunate to reach out in different ways. And one of the things that we've been able to do is establish a pretty interesting relationship with Lockheed Martin and what they're doing for the Orion program. And the whole point of this was to say, if we've got two types of programs going into space, could they talk? Could they work together? Is there a way to cooperate, which had never been done before? And over the last couple of years, we've been really fortunate to be able to say, what can we do between what Lockheed is doing with Orion and what we're trying to do with Dream Chaser? How can those two come together and work together? And what we found is that there is just an amazing amount of things, from how we certify in terms of requirements and safety, to how we go ahead and build on the future of the technology that we're developing. We are working together to try to use the Armstrong Operations and Checkout Facility, where Orion is going to be checked out. It's where Apollo was checked out. And to be able to use that same facility, which might produce 1 flight a year for Orion and then not be used as much for the rest of the year, to be able to process in that facility, suits the government, suits us, and helps Lockheed. It was really a wonderful 3-way street. We also are using environmental facilities that exist. And the ability for Lockheed as our partner and as our vendor to be able to open up some of the facilities they're doing for environmental testing meant that we didn't have to go out and do that and buy it. It was already there. It was world class. And we took that even further, and they came on board, and they're helping us build the composite structure. And that's being done in 2 places. The first is at the Michoud facility in Louisiana, which is NASA's facility. It's the same place where the Orion structures are done. And we're building from that position. We're helping to build the composites, and then we're going out and taking that and moving it to the facility in Fort Worth where the Joint Strike Fighter is being used. To be able to do that, to take advantage of that whole infrastructure, has been a terrific way for us to move the program forward. We have now completed over 30 different milestones in the NASA program. We're still working under the contract that we have. We've been flying. The next flight of the vehicle is shortly coming up. And we believe that we are doing pretty well in terms of developing the next generation. We're actually building the first orbital vehicle. It's under construction. So 9 years ago, when I first started getting into this, we said, well, we wanted to go out and maybe build a replacement for the space shuttle. And we had a group of about 30 people at that time in a garage in San Diego. And it was a pretty amazing, audacious kind of thing. But that's what life is about, trying to do big, audacious things, like starting this conference and having New Mexico be a leader in this type of work. It was probably not something that was thought about when this was only a farm museum and instead of becoming a space and farm museum. And we felt the same way, and we've been able to move it forward to the next level and take that dream all the way from a thought 9 years ago to actually starting to fly something, as we've been doing. You know, there's a lot of, in our view, there's a lot of capsules in the world, and there's a reason for them. We're not anti-capsule at all. There's a purpose for them. But there's also a reason that we built the shuttle, and there's also a reason we put so much money into lifting bodies and the kinds of things that we do. And many of those things are very suited to what the next step in our future is. And that is, if we're going to do research, if we're going to be able to go out to the space station, what are we going to do about that? Why are we even going up there? It's not to take pretty pictures. We want something, in our view, to be able to be a utility vehicle, to be able to come home at low Gs, to be able to bring those scientific experiments home safely and quickly, and to be able to do that in a way that really helps expedite the research that's going on. And many of you know the space station, you may not know, is now officially a national laboratory, which is a wonderful thing. And what I've been spending a lot of time is look at what's going on up there. Why is it so important? Because I get asked that a lot. Why do we have a space program? Why are we spending billions of dollars? And I try to talk to people about that. And there are many things, and I just pick on 3 or 4 of them. The fact that we're learning how to deal with muscle atrophy, which affects so many people who can't move out of their homes or in the hospital. That technology, understanding how to make that better, is going to make so many people's lives better. We then also look at the advancement of disease treatment. We don't have to go too far today to look in the paper, but the idea is that you can actually make things accelerate or decelerate in space. If you need to do a vaccine, we've been figuring out how to make that happen quicker in space. That could be a really important thing for us. Visual impairment, one of the first things that goes when you're on the space station is your eyesight. And to be able to understand how that works and be able to move that forward is going to directly affect a lot of people who are having issues with their eyesight. And my personal favorite is the work that's being done on brain issues, particularly Alzheimer's. There's been a lot of development in that area that basically has said that we understand that Alzheimer's may move slower in space, and now the research is telling us what Alzheimer's is, or potentially is. It isn't what we thought it is. It isn't about parts of the brain dying. It's actually about parts of the brain fusing together. This is all terrific work. If you can imagine just that one thing, if we could bring that home and bring that home safely and be able to help 1/3 of us who will have that particularly horrible disease, that's, I think, a pretty important way to go. So I'm going to end up in the next few minutes just telling you a little bit about the future and where we're going in the future. And that came from the Mars program, the bouncing ball thing. One of the things we announced a couple weeks ago in Toronto was our advancement into what we're calling our global project. And essentially what that is be able to package a space program, a Dream Chaser flight, a rocket, ground training, all the elements, and be able to bring that to countries who don't have a space program right now. We've been working on this for almost 2 years now. We have a pretty significant amount of effort put into it. And we're sort of a company that announces things after we've spent some time looking at them. But the idea of being able to give countries the opportunity to have a space program is pretty exciting, and it's gone pretty well. And we've been able to put together a multinational presence around this. We actually have now organizations from 21 space countries that are part of what we're doing. And a number of not only space agencies, but also organizations that are building in these countries. And the idea is, can we look at this globally? Should we look at this globally? And we think we should. We also announced our continuing development of the vehicle. When we first designed Dream Chaser, we looked at how do airplanes get designed and how do cars get designed and other things similar to that. And we realized that you can do a family of products. It's not a vehicle in doing one thing. It's how do you do the most things from the airframe, and then how could you vary the airframe to be something unique? Lockheed builds a C-130. That C-130 has 8 different missions, from firefighting to medical to be able to drop troops to be able to handle cargo. And it's the same kind of thing that we looked at in space, maybe for the first time, looking at this in a way that's very broad. And recently, we have been developing a version of the Dream Chaser that could potentially launch with Stratolaunch. And we talked a little bit about that in our press release and in our Toronto rollout of this a couple weeks ago. And it's pretty exciting. And basically, it is a 75% scale of Dream Chaser that is sized and would fit into that type of airdrop orbital type of operation. And it's something that we know that can work. We can take the design that far down and keep a vast majority of the technology that we've been developing. And basically, for us, that falls into 3 categories. We think that there's, in low Earth orbit, beyond the missions of just transport, we're able to do servicing in space. There are dozens of major satellites that are really important to us, particularly the weather satellites, that could be used to be serviced, that could be used to be fixed, and we think that's really important. The other thing we can do with this platform is to do science. The interior volume of the science version of Dream Chaser is about the same volume as one of the modules on the space station, but it can act in a free flyer capacity. So it can go up for a year, do that science, do that laboratory work, and come back home, be re-outfitted with new equipment, and go back up again. And we think that makes an awful lot of sense for the kinds of applications. And I want to just finish. I started with John Glenn. I want to, obviously, many of you know what this is. It's a particularly poignant picture. But shortly before Neil Armstrong passed away, he was actually on his way out to see us because he, too, like John Glenn, was so curious about what we were going to be doing and how he was going to be doing. He didn't know if he bought into it yet, but he was on his way out. And one of the things about Neil that was particularly wonderful to me was he was so precise in his thinking. And I don't know how many of you know, but the most famous saying that he did from the moon for almost all of his life, he basically said was wrong. And the story goes that apparently you can imagine you're going to be the first person on the moon. You might have given a little thought to what you might say. It wasn't shooting you from the hip or not talking from a script like I'm doing today. And he did, and he said those words that became famous around the world even before he came home. The problem was what was reported wasn't what he said. And for the next remainder part of his life, he decided that he wanted NASA to correct it, because if you actually think of the words, one small step for man, one giant leap for mankind, it's redundant. And there was actually a little A in there. And the little A can make a really big difference in life. So he went for a long time, and many of the places in NASA actually have the corrected version of this, and there's been people smarter than I figuring out what happened in the transmission. But I hope today there's something I give you a little bit of enlightening, that I didn't miss any A's in my conversation, and that we can all move forward and really see the future of what goes on here. And one of the things I think is most important is to keep your passion alive. And one of my favorite songs is an old song called Up on the Roof, because I think many of us can relate to wanting to go up and look at the stars, and as a kid wanting, in my case, being able to go up and build airplanes and fly to space. And it's really something that we want to remember. And whether or not your roof is a building looking out over the Pacific or looking out over the Atlantic or atop of a mountain in Colorado, we all have that dream and that passion to want to make something better, and that's why we're in this industry. And we really do believe that you can keep your dream alive, and it's about taking a chance. It's about being able to follow your passion. Sometimes it's not always obvious, or sometimes it may not be the thing that's politically correct, but there is that. If without that passion, it really doesn't make life doesn't make any difference, in my view. So it's really never too late to dream. And thank you very much for listening to me today.
So Mark, we have a couple of minutes for questions, and I'm going to take liberty of being the master moderator. So
that means I have to answer.
You must answer. Cornerstone to your program is these partnerships that you've built up. What would you say are the top 1 or 2 lessons learned from those partnerships, in particular with what we would call, let's say, traditional aerospace? We've seen a lot more of those announced, Blue Origin and ULA, Northrop Grumman and Virgin Galactic. We heard from them earlier today. What are your lessons learned?
I think the first thing is, the first question you ask is, how does it benefit the other side? I think in the past, a lot of people said, here's what I need, tell me how you can help me. We've taken the position of saying, we know what we need, let's hear from the other side, let's hear from the partners. How does, in being involved in this, how would it help you? Particularly if you're dealing with companies that aren't traditionally companies who partner, or countries who partner. So we spend a lot of time not trying to sign a deal, but actually trying to get to know the other side. Maybe even very much like an Eastern philosophy of spending time with people to get to know them. Because truly, if these kinds of partnerships, the things we do don't last 6 months, they last 6 years or 12 years. And you have to build that foundation before you can actually get to sign an agreement. Most of my agreements didn't get signed for a year or more after we started talking, and that wasn't bad. That was good, because when they did get signed, it was almost a fait accompli. It was not something that was we had to negotiate. We knew what we wanted, and it turns out to be a lot stronger.
How would you characterize how you've been able to work with other organizations and their different processes, right? A lot of what we've given credit to the NewSpace industry is coming up with better, more efficient, less expensive processes. How do you meld those and different cultures? when you're working with your partners?
Yeah, I think probably the easiest thing to say is that you have to have a respect for what has happened. Just because it might be cumbersome or large or difficult or things that may not fit into the mold that we have, doesn't mean that it's all wrong, or it doesn't mean it can't be worked. So we take the time to say, instead of just saying we have a better way of doing it, we look at what happened. Like I showed with Lockheed a little bit, there were many things that aren't going to fit in our program, but there were quite a few that did. And that what we spend our time doing is trying to figure out which ones would work and which ones didn't. And in the course of doing that, we're actually helping each other.
Right.
The composites work that they're doing, well, most of the composites that's been done by the Skunk Works operation have been composites in 4, 5, or 6 Gs. We're going to 25 Gs.
Right.
So they're learning with us about how to do that, and that will make them better. And trying to figure out how to do that sort of triangle where each partner gets something useful, and as does the end client get something useful, is where we go from. And I think that comes from being humble a little bit and realizing that you don't know everything. So let's not just say it doesn't work. Let's not just say we can't use it because it's too expensive.
Great. Thank you very much.
You're welcome.
I really appreciate it.